What is up, everybody? It is Shaban, and we are going to be answering the question, what is the best game programming language? Oh, shoot, we're going there. All right, so stick around to the end. No cheating, because first we got to lay the groundwork for this conversation. So I'm going to start off by talking about this little subject of programming language versus scripting language. Okay, you're going to hear that a lot, especially among elitist groups. They're going to be like, scripting language or programming language. See, well, when we're talking about programming languages and scripting languages with the context of game programming, game development, it's kind of a silly conversation because usually when we're talking about a scripting language, the scripting language itself is almost always, or at least usually, a programming language as it is. We're not going to be covering, like, what is the definition of a programming language? Is it Turing complete and all that kind of nonsense? But you would maybe reframe this as perhaps game engine language versus game programming language, or gameplay programming language, or something like that. So you can kind of frame it in that kind of way if you want. But really, it's not necessarily quite that simple because there are a bunch of different types of scripts or scripting languages. For example, there's shader language like HLSL, shader languages too, and like HLSL, or maybe even like a narrative or dialogue language such as like RenP or RenPy. So anyway, we can get to that maybe another time. But basically, when I'm talking about scripting languages today, I'm mostly referring to game programming languages, the gameplay programming languages, and not the game engine language. So what do I mean here? I'm actually going to get to that little topic here in a second. What do I mean by engine language versus this game programming language? Well, you see, game engines are written in what we call a native language, right? It's a low-level language that is highly performant, and you would often see C++ being the language used to write the game engine, okay? So, for example, Unity is written in C++. However, there's a layer on top of it, which is C#. Okay, so the engine is written in C++, but C# is what you might call the scripting language on top of it. It's where the users of Unity, the game programmers who use Unity, are going to be writing their gameplay code and their logic and making their games actually work. And that's why I would say game programming language, because that's where they're programming their games. C++ is where they're programming the engine. Okay, so there's kind of a separation. This is the scripting layer, more or less, and this is the engine layer. And there's some communication between these, but typically the user doesn't have direct access to that native language, to the source code for that game engine. I mean, perhaps they would, but to have that access from the C#, from the scripting layer, is typically not something that is afforded directly. Okay, so there are other game engines. So for example, another game engine written in C++ might be something like Godot. Okay, so I'm going to say this is Unity, and then this might be Godot. So when I say C++, I'm also kind of meaning C++, so it depends on exactly what the operation is. And then on top of that would be GDScript. Okay, so that would be kind of the scripting layer, or actually, Godot always likes to do things differently. It's going to be a pentagon, or maybe even visual script, okay, depending on what you want to choose. And then there's also Unreal Engine that uses Blueprint. Okay, so this is Unreal Engine and its game programming language on top of it. So this is UE4, would be Blueprint. And before you're like, well, Blueprint's not a programming language. Well, actually, Blueprint is a programming language. Sorry about you. In fact, I'd like you to go talk to people who use sign language and tell them, you're not using a real language. All right, because for all intents and purposes, Blueprint is a game programming language. It has its own syntax. It has all of its own features that you would expect a game programming language to do. You just happen to be using nodes and wires and all that kind of junk. All right, we don't have to have this debate. In any case, what I want to be able to convey here is that there is this separation. And actually, I'm going to go to this. So there's Sucker Punch, right? So those are all off-the-shelf engines, but Sucker Punch is talking about how they have their own like proprietary scheme-based scripting language. Holy moly, what the heck? Okay, so Scheme is like a Lisp kind of language. Some colleges teach it, and the students often hate it. They're like, what? I'm never going to use this ever again. This is not industry, or something like that. But as you can see here, even Lisp-based languages, functional languages, Scheme in this case with Sucker Punch is used as a scripting language on top of perhaps C++. Now, I don't know this particular in-house, is what we would call it, in-house engine, but with the sake of Sucker Punch's engine, you could probably assume C++, maybe, maybe not, and then on top of it is Scheme, right? So why the heck would we use why don't we just use the engine language? Why, it's C++ across the board. Is that the correct answer? Game programming, the best one is C++? I guess you could argue that, but why are you even creating these additional layers of GDScript? If you can write the engine in C++, then you could write the games in C++ as well, right? And absolutely you could. However, they make that scripting language on top because the native language, the C++, is typically, or other native language that might be used for this, is typically have a much higher learning curve, much more chance that you're going to break something, and so it's a lot less accessible to beginners, gameplay programmers, or other types of people. So it's difficult to attract users or programmers to the engine when you are, requiring them to use a language like C++, which has much higher barrier of entry. And perhaps also the scripting languages provides features that are more specific or optimized for a specific type of programming. Otherwise, why would they choose something like Scheme? So Scheme is really potentially good at creating functional algorithms, so perhaps for artificial intelligence or other things like that. So you have to make those types of considerations as well, and that's what we're going to be covering. There's one thing that I want to say before I move on, which is, oh, actually, I might as well just throw in a different one here. So let's say Python and RenPy. Okay, so RenPy is like, it's not even a programming language, right? It's more of kind of like a command-based language that is mounted on top of actual Python where the engine is actually written, if I understand it correctly. So here's kind of scripting languages versus programming languages. But one thing that I want to kind of mention is kind of a notable exception to what I've been talking about, and those are JavaScript-based engines. So JavaScript-based engines, we'll be talking about more of those later. Really, the scripting language is also JavaScript, right? And it's an upside down pentagon because JavaScript is weird. Sometimes it's TypeScript, right? Depending on the game engine. But the point is that when you're doing a web-based language, a web-based game engine, JavaScript is where the engine is written, and also the scripting language is typically JavaScript. So it's pretty interesting, and maybe more to see of that in the future to come. All right, awesome. So we understand scripting languages versus programming languages. Now what we have to understand is the concept of an embedded scripting language. Okay, what the heck do I mean by an embedded scripting language? What the Jimmy? Okay, so I'm gonna actually bring this up here to have this kind of as a conversation point. Embedded scripting languages. Okay, for us to be able to really understand what an embedded scripting language is, let's first take the example of an in-house game engine. So for example, Sucker Punch has an in-house game engine that they wrote, C++, and they've got Scheme as the scripting language on top of it, just inferring from the job posting. But the question here, though, is what does an in-house engine, what benefits you from having an in-house engine versus like an off-the-shelf engine? That's not really the conversation for this specific video. That's for a different video. But if we could boil it down into essentially just a single sentence, it would be that off-the-shelf engines allow you to create almost any kind of game. In-house game engines, on the other hand, are designed to be used for a very specific kind of game. So if you're a studio that's using, I don't know, this is not really a single sentence anymore. If you're just creating like freaking Connect is it called a Connect 3 game? No, it's not. It's called like a Match 3 game, right? So you got like, then you do the Match 3 and it goes kaboom and there's candy explosion, all that kind of fun stuff. If you're creating a specific Match 3 game and you're just creating all sorts of different Match 3 game clones, and that's just what your studio does, you could create an in-house engine that's very specific for Match 3 games, right? And so you would create an in-house engine for it. And so that's the same with many other game studios. We could talk about all the benefits of using an in-house engine, all the cons, but generally speaking, you optimize the engine and the workflow specific to a type of game, and very importantly, you also exclude all the stuff you don't need, right? If you don't need multiplayer, network multiplayer, then you don't put it in the engine, right? So you're able to streamline your game engine for the very specific purpose of that game engine. And so with that being understood, this is how we can understand embedded scripting languages versus what you might call an off-the-shelf programming language. There's not really a term for that necessarily, but you would potentially say something like a traditional programming language, or perhaps like an industry standard programming language or something like that. So an embedded scripting language is the same thing. It's almost like a corollary in some way to this whole idea of in-house versus off-the-shelf game engine. And specifically, if I just reword it, is that an embedded scripting language allows the game engine developer to create a language that is optimized for the very specific features that the game engine requires or game development uses, and it is able to cut out all of the fluff, all of the excess baggage that they don't need for that particular game engine. Okay, so that's the advantage of using perhaps an embedded scripting language. So if I, were to be specific here, GDScript, right? So GDScript is not a language that you would find anywhere outside of Godot. It is a proprietary language specific for Godot. And it looks a lot like Python. So oftentimes it's asked the question, why the heck wouldn't they use Python? Python's like a super popular language. It's like the most popular in the world. What the heck, Godot? Why do you not use Python? Right, and they've answered that question like 100 times. As an understatement, but so why would they do it? And it's the question about, well, why would you have an embedded scripting language? And so with the example of Godot, they're not shooting themselves in the foot by not choosing Python. It was a deliberate decision, right? And it's because in the case of GDScript, you're able to offer native types that don't belong in Python, that are fundamental to game development, such as vectors, right? So vector is like a common problem because it's not really found in many or most programming languages, right? Probably almost all programming languages doesn't include vector, but GDScript does. It's built in, it's native, it has all the methods and all the properties that make it specific for game development. So it's powerful, and then that includes all the other types of types that are specific to game development outside of just vector, right? And also GDScript offers much better threading support. Maybe I should be writing this down. I'm gonna write it down, guys. Okay, right, so why would GDScript be used? So native types like vector, right? What else do we got? We got better threading, right? Support. Python's threading support, pretty thin, not so good for the purposes of game development. Okay. Also, you can have a better and more custom tailored, let's say custom tailored, more effective garbage collector, right? So you don't necessarily need to know what a garbage collector is, but it allows you to prevent problems such as stuttering and such as stalls and other kinds of issues. You can avoid that kind of stuff by creating your own custom tailored memory garbage collector. Okay, you can essentially just all the other kinds of flexibility. So it's just hugely flexible, so that as trends, game development trends, as the engine evolves, as users kind of give feedback about the types of features that are inside of the language, that you can change the language. And that's what has happened already multiple times with GDScript. They've made breaking changes to how the game engine, or how GDScript works, and actually even like the terminology that is used in GDScript, because it's more intuitive, because it matches kind of workflows a little bit better. You have that flexibility to make those changes on the fly. You wouldn't want to do it on the fly, but at major revisions of the game engine. you can't really do that with Python because you're grounded in with whatever Python has. And then also, let's consider what are the drawbacks of having to choose Python, right? So the drawbacks of choosing Python is it is bloated with like extra junk. I'll say extra junk. All sorts of other stuff that you don't need. That's part of Python. You just don't need it. So it's just extra tools that'll just confuse beginners. It's like, what is this? Why do I need this? And it just keeps things not very streamlined, right? And you're going to see tutorials that are using all sorts of different libraries that aren't specific to game development, and it can get kind of hefty or higher learning curve for those beginners getting into the engine. Also, if you were to use Python, you would have to keep up with versions, right? So there's all sorts of crazy versions. Like some people are like 2.7, 3.6, and all this kind of stuff, 3.7. And as these versions come out, sometimes there are these big changes. Sometimes there's a problem where someone has multiple versions of Python installed, and so they are running into those problems, and then you have to troubleshoot those things. And those are just issues that game developers don't really necessarily want to just see floating around in the forums all the time, and instead just keep everything to specific versions. They come right out of the box. You don't have to worry about installing those separately, different runtimes, different platforms, or anything like that. And then finally, it's difficult to integrate. So difficult to integrate into the kind of proprietary, custom, cool features of Godot. So for example, something like live code editing, where you're like editing code as the program as your game is running, and all the other cool features of Godot and GDScript, you wouldn't be able to do very easily with Python because like the way that Python is written is outside of the development house. So you have to essentially create all sorts of extensions and kind of hacks to try to make these types of things work. And also, if you're going to be including the code editor inside of Godot, it's also more difficult to be able to do that. Assuming that the user has actually installed Python, and to offer those awesome features like code completion and those types of things are harder to be able to create if they were to try to use Python. So there are reasons, as you can see, why you would use an embedded scripting language. You would write your own programming language specific for the game engine. And as you can see, maybe this is the way to go. But then what the heck about Unity, right? So Blueprint has its own things too. Like Blueprint offers features that programming languages don't, like other typical programming languages don't, like multiple outputs to a function. It's like, what the heck? And all sorts of cool logical structures that you just don't see as part of traditional programming languages, and gates and all sorts of cool stuff. So Blueprint is actually really powerful, and you might even argue that it's more powerful than C# is in it kind of like a core functional way, not necessarily in its extensibility. Okay, so then why C#? That seems kind of weird, and it is kind of weird actually. Unity is a little bit weird that they went with C#, which is not an embedded scripting language, right? This is not a language that's embedded into the game engine. It's a language that is ubiquitous, that's used for any number of different programming fields. So why the heck are we using C#, right? We have some of the problems that we have with C#, you know, with like having difficulty to integrate maybe, and you can't, right? Unity has this kind of round trip workflow with like Visual Studio or, you know, other types of offerings that you might see like with JetBrains and that kind of stuff. There's no C# editor built into Unity. They can see that right away. They're saying like, we're not doing that, right? And so you have to like save it, and then it loads it back into Unity, and it's pretty good, right? It's maybe not quite as well integrated as something like GDScript, but it does its job, and you're able to do some kinds of cool live editing types of things, but it's pretty limited. So what the heck? Why would we do C#? In fact, it has other problems too, such as all sorts of boilerplate code that isn't necessary, right? Like we're like using libraries in C# that we don't need, right? And in fact, usually you can just delete those like using statements at the top of Visual Studio Code when a C# file is created for Unity, and it doesn't make any difference because those additional libraries that are loaded in, are we doing okay on time? Yeah, those libraries that are loaded in are just not necessary, right? But there's other things like, so events, right? So events inside of C# are kind of weird, right? The syntax is a little odd, and coroutines is kind of odd. And Unity, I kind of infer their concession to that fact by the creation of things like Unity events, which is a little bit different than other events and serves a little bit of a different purpose, but also things like invoke, right? The invoke function. You don't necessarily need to know what all this means. In fact, I'm getting a little sidetracked here, but the point is that C# or Unity knows that this boilerplate code can be a barrier to beginners jumping into C#. So why would they choose C#? Well, there are benefits of using a language that is not exclusive or not proprietary to the game engine, and in fact, Unity's success should be testament to that strategy, right? So why would they do it? And so if I can just like throw an additional list down here. So why would we use something that's like not an embedded scripting language for our scripting language, for our gameplay programming language on top of our engine? And so perhaps, let's see. Yeah, you get access to C# libraries that work across different fields, right? So you get access to C#'s huge collection of libraries, not necessarily even just written by Microsoft, the developer of C#, right? So this allows you to be able to do things to extend, to have hardware support for all sorts of cool different tools or things that exist in other places, like for maybe if you want to include some kind of crazy web scraping or something like that in your game development. And you wouldn't be able to do that with something like Blueprint or GDScript as easily, because web scraping is not something that's typically in part of game development. So these kind of edge cases type of things are just maybe extensible with something like C#, and you'd be able to do that with Unity. So that's pretty cool, right? You get also, it attracts programmers who are also already very comfortable C#. Attract C# programmers. So there are people who already know how to use C# because they use it in their work for their other jobs that are not game related, and they're like, well, I want to get into game development. What should I use? Well, this game engine already, or this uses a programming language that I already am very familiar with, so I might as well just go with that. Maybe that should be my starting point, right? You attract C# programmers, you attract them by attacking them. Anyways, you attract also perhaps developers who want to get into game development, but they have no illusions about the difficulty it is to make bank with indie game development. So it's like, if I try to get into game development and it doesn't work, right? It doesn't pan out. What's my exit strategy? What's like the backup plan? So if I'm going into Unity and I'm using C# and I'm getting really good and adept with C#, then I have a more direct exit strategy where I can use those skills. I can say I have multiple years of experience with C#, which will enable me to be more attractive in job markets outside of just game development, right? So attract scaredy pants indies. No, attract I don't know, developers who want an exit strategy. Hopefully you just know what I mean and you're not like muting this, right? Hopefully you're listening to this, because otherwise you're like, what the heck does that supposed to mean? Anyway, so let's continue going. Okay, so that should hopefully cover like why we would use an embedded scripting language, and maybe why you wouldn't, right? In fact, if you think about it, also for the case of C#, the fact that GDScript also offers C#, right, after they've developed GDScript, it's like that kind of implies that there's a reason to use it. Otherwise they wouldn't have included it. Why would they like waste their time putting in C#? Maybe it's because Microsoft gave them a little bit of money for it, but probably not, because that was specifically just for developing C#. Why would they do it, right? So right there, it implies that there's some value in having something like C#. And I'm going to hold off on that until I talk about my opinion of what the best game programming language is for later. Okie dokie dakey. Okay, so let's let's go to the next topic, which is before we talk about like the fun stuff, what's the best programming language, game programming language, let's talk a little bit about something called an event sheet language. Okay, an event sheet language. I don't want to say an event-based language, because what does event-based mean? Like defaults, Lua, it's kind of signal-based, messaging-based, or GDScript signals, and what do they mean? So event sheet language, I'm not talking about those. I'm talking about the language, the game engine is built around the proprietary event sheet language, and that includes engines such as Construct and Clickteam Fusion and GDevelop. So these are kind of the big names here in this space. And so you might be like, wait a minute, like, well, what about like other languages like Blueprint, right? And Godot's like Visual Script, or maybe even Bolt for like Unity, right? Unity's Bolt. That seems kind of suspiciously like Usain Bolt. I think there's some kind of subliminal messaging here. Anyway, why would the heck again, you would know what I mean by this if you're listening, and hopefully not just like putting this on mute, right? So this, not like, okay, I'm just gonna even write it, not like these. I want to say there's a clear distinction between these. It's not just that constructs, Clickteam Fusion, GDevelop are visual scripting systems, but it's very different than Blueprint, Visual Script, and Bolt, which are also visual scripting systems. So what's kind of the clear difference? Well, the clear difference is kind of how they're formatted and how you think as a programmer. They're fundamentally different with how you think as a programmer. When you program in Godot or Visual Script or Bolt, you're programming like a game programmer using the traditional methods of game program. That was weird. The traditional methods of game programming, whether you're using Unity or C# or GDScript or C++, okay. When you're using an event sheet language, one big difference is that the event sheet language, everything is kind of like in a global context, right? So event sheets are global, and they're not attached to objects. Okay, they're not attached to objects like you typically find in these other languages, or they're not. It's not class-based, right? So the Blueprint and Bolt and all these types of things are essentially based in the idea of classes, around this idea of objects. But things like Clickteam Fusion, GDevelop, Construct, they're not. They're based in a global kind of scope. And that is a little bit more intuitive to beginners, because instead it's kind of like a rule sheet, right? So a rule sheet where you're able to say, like, this is a rule, this is a rule, this is a rule, specifically in the form of action, reaction. In fact, I don't want to say action, reaction, because that'll actually screw up the terminology. They'd like to say event or condition, conditions, and then actions, okay? So action, reaction, the same idea. There's a condition that occurs which results in what particular actions, okay? And you have just a list of those rules. That is a totally different way of thinking about game programming, in my opinion, and much more accessible to beginners. Working in that way is much more accessible to beginners. Okay, so for example, if we were to consider just for a second, you're creating a game where you're catching frickin', I don't know, butterflies, right? So you've got this butterfly, whee, and then you've got another butterfly. Oh my gosh, people, take away my stylus, or maybe get me a better freaking tablet. Anyway, yeah, right, the tablet will make me a better artist. All right, and so in this game, you catch butterflies with a net. And here's my beautiful net, and you catch butterflies with this net. And then there's other butterflies outside here that are not cut. That was a shortcut. That's a butterfly, people. All right, so you catch butterflies with a net. So how do you write this? Well, when you're doing something like an event sheet language, what you say is net collide, or let's say on net collide blue butterfly, right? And destroy butterfly. I know we're destroying them with love, okay? So destroy just means we'd remove them from memory, okay? If that makes you feel better. All right, so they're gone. But that's how it works. It's like on net, collide butterfly, destroy butterfly. That's it. That's all, right? If you just want to make it so that for this particular moment of the game, any butterfly that is colliding with the net will destroy the butterflies. And it uses what is called a picking system, right? So if there's 4 butterflies and 3 of them are colliding with the net in a particular frame of the game, this will select select only the butterflies that are colliding with the net. And then when you call the action destroy butterfly, it will automatically take that picked list of butterflies and only apply the command destroy to the picked list of butterflies. Beginners don't realize that that's what's happening on the back end because it just works for them, just typically out of the box. But if you were to do something like, Visual Script, Blueprint, or that, you have to frame this the same way that you frame your other code, where you first have like a freaking update function or like tick, some kind of update or tick function or some kind of thing like that, process even. And this is a function that runs every tick. And so already it's kind of confusing because it's like wrapped in this other function, and the script belongs to like an object. So now it's like already mounted in some kind of something or other. So the user already is like, wait, where? And so if let's say we're doing this in the global scope, how would we do it? If it were in the global scope, what we would have to do is we'd have to say something like, you'd use like a variable to say like collided, objects or something like that. Equals, and then like get nets collided objects, and then you'd have to go in here and do like a loop. You'd have to say like for each object in of collided objects. This is no language's syntax, by the way. Then you'd have to like check to see, is it a butterfly? And then you would say like, okay, well, if it is, then destroy it, right? And that object, right? Whatever that is. So like this, I don't know, if you're a programmer, please have some sympathy, okay? This is just not very clear to a beginner, okay? And it doesn't make it much better when you're like, well, just put it like in the butterfly. Well, you have to think to then create an object, attach it to the butterfly object, right? And now that's the idea of like, there's this butterfly class, and like there's instances of that object, and it's running on each of them. This is not intuitive to a beginner necessarily. And then you still have to put it inside of an update function, and you still have to check if it collided with a net, right? Not just like with something else or some other butterfly. And so that's that idea of like you're dealing with types and this kind of stuff. It's just not as intuitive. And so we have these event sheet languages specifically for beginners, and it just works in a way where they don't have to go through that dissonance of trying to understand how to think like a computer think. What's the word that we say? Computationally. Okay, so anyway, now that we've covered event sheet languages and the consequences associated with them with game programming, let's now I hope that you could see all of that inside of the window. Anyway, let's now talk about what is the best game programming language. Okay, now that we understand what all these different languages are, what is the best game programming language? Okay, so we're finally get to ask that question. Did you place your bets? What do you think it is? This is amazing. We're about to know the answer. Well, the boring answer is the correct answer. Okay, it depends. Right. So the best maybe I'll get to something a little bit more concrete here in a second. But when we're talking about programming languages, I recommend taking a project first approach. Figure out what is the project that is being created, and then figure out what is the engine or language that best supports that particular project. So now I'm going to go step by step, talking about the different types of projects and maybe what you would consider to be the best game programming language for that context. Okay, so let's start out. What if it's a web game? Web game. What is the best game programming language for a web game? The answer is, are you ready for this? It's JavaScript. You didn't believe that. You weren't gonna believe it. Okay, it's JavaScript. Is pretty much it. And sure, you can use Unity. You can use Unreal, debatably. You can use Godot to be able to export to the web. But here's the problem. When you do that, you're taking this C++ code, this like native code that has been written for the x86 processor or some other kinds of processor, and you're trying to be able to make it run natively in a web browser. So code that runs natively in a web browser is called JavaScript. It's called HTML. It's called C++, or CSS. That's what SS stands for. It's ++. C++. All right, so, but JavaScript is the programming language that's native to web browsers. So what the heck happens when you export a game from Unity or Godot to the web? Well, it has to convert it somehow to JavaScript. And it does that with something like Inscriptin, and then that transpiles the code all the way over to this thing using WebAssembly, like, you know, runs then the JavaScript in this WebAssembly or ASM.js or whatever the heck they're using, probably WebAssembly. But there are a lot of problems with this, okay? When you're doing it this way, instead of just writing the darn game in JavaScript alone, you got these types of problems, okay? You got longer, I need to separate this out here, okay? You got longer load times. You're using more memory. It's less performant, so fewer frames per second. Okay, what else? Less compatible. Compatibility. Okay, so there are many mobile devices that don't support the WebAssembly that you got through Mscript and all this kind of stuff. It's just not as well supported. Also, just cross-browser support is less consistent. It's not very good, in my opinion. Now, some of you are like, I made all sorts of Unity games. I put them on itch. They're great. It's like, well, I'm happy for you, okay? But all things considered, if you're creating a web game, it's going to be the most performant and compatible, accessible, and all this kind of stuff if you wrote it in a JavaScript-based game engine. So when we're talking about a JavaScript-based game engine, that's something like Play Canvas and Cocos Creator, which is now got a 3D version, which is pretty cool. So Cocos Creator, Play Canvas. What else do we got? We got all sorts of fun stuff. We got Impact.js. No, Construct 3. Let's do that. Construct 3. That one also counts. That's native. The game engine itself is written in JavaScript and it's based in the web. Why did I put Impact.js? That's fun. We got Phaser. We got Panda. We got even freaking Wade. Throw that in there. Call out for you. There's probably a big one that I'm forgetting, but you know what? Oh well. Anyway, so these types of engines are going to create the games that are going to be most native for the web. Okay, so then what else? Well, let's say that you need some kind of very specific extensibility. Okay, so for example, let's say that you want to create a game that controls some kind of really interesting controller through like an Arduino, right? So like some microcontrollers. So if you have some kind of specific extensibility, and I don't want to say specific, it's, let's say like outside of games, you know, extensibility, such as like you're trying to control some kind of really cool, pretty niche product, like, you know, such as Arduino or something like that, over some kind of serial controller, you know, some like LED kind of thing, or, you know, some kind of really cool stuff. That stuff is typically not built into something like GDScript, right? You're not going to have the kinds of like control serial, you know, through some kind of driver through GDScript, right? So that I would recommend something like C#. Okay, C# would be the best use for that, and so that is something that I've done, right? There's like a very specific custom project that I needed to do, and how was I going to be able to do it? Well, there's a library for it, but that library was, you know, specific to .NET, to C# to something like that, and so in that case, got to use something like C#. And you can't use other types of languages. And even if you could, you're doing all sorts of weird hacks to make it work. You can just use libraries that are specific to that specific extensibility using something like C#. So that's pretty neat. That's what I would consider to be maybe the best language for that type of thing. Really, or whatever else. You know, it depends on the particular application. Let's say that the context is that your client is inexperienced. You're creating a game for a client, and that client is inexperienced and needs to update game. Okay, so for example, you're creating a educational game for like some instructional module for some kind of class, some you know, elementary school class or some college level class, and the client is paying you to create some kind of instructional module. So what kind of game engine should you use for that? You might be tempted immediately to be like, well, I'm a game programmer, so I'm going to use a game programming language because I'm better than, you know, the dumb languages. But really, for this, I would say an event scripting language, an event sheet language would be my go-to, and what I would consider to be the best game engine, game language for this kind of use case. If they have money, Construct. If they have no money, GDevelop. Pretty much, right? I mean, that's pretty opinionated, but the point is that when you have your client is inexperienced, and I've done this several times, you know, there's no need to flex like, oh, I can do game programming. No, if you create the thing in Construct. If you're really a good game programmer, you can use Construct, believe me, or you can use GDevelop. You create the application in GDevelop, especially if it's like a relatively simple, lightweight, and you can publish it to the web kind of situation. What you do is you take it, you develop the application, and you just like create this event sheet that's really easy to use, and you just say like, hey, look, if you want to change something, you just change this little button right here. You can drag stuff around inside of the layout view. Super, super easy. It's easy to train them on it. You can be like, well, you can like, you know, custom create like some kind of Godot, you know, add-ons or plugins or something like that where they can also just click buttons. Sure, you could do that, but you're kind of running the risk of like then it can't be updated very easily. Like you're still on the hook. Don't try to do this kind of weird freaking job security junk so that like they have to come back to you to fix it for your own sake. Trust me, it's the worst when they have to come back to you. Let them free. Give them a language. Give them an engine that they can continue to update. Okay, it's a lot better. In my opinion, event sheet languages are the best for that kind of use case. Get used to it. All right, if it needs to be incredibly lightweight, okay? So if it needs to be freaking light, is that really what I wrote? Lightweight? Lightweight. If it's like a super lightweight application, such as Raspberry Pi, something like that, then I don't recommend a big game engine like frickin' CryEngine or even Unity or Unreal. They're not going to run on a Raspberry Pi. It's just not going to work. On this ARM processor, this little stupid thing, it's not going to work very well. I would recommend something lightweight, like GDScript. Okay, Godot is like very, very lightweight, and it's open source. So you can compile Godot on a Raspberry Pi. I've done it before. It's really not that hard. You just take the freaking source code, you compile it on the Raspberry Pi, and then you can use Godot on your Raspberry Pi and create your game on the Raspberry Pi for a specific really cool kind of modular installation, some kind of like arcade thing or arcade cabinet or some like LED thing. Who knows? You could do some really cool stuff. Maybe even like, you know, something that you would put inside of a mall, like something that like is like directly monetized through quarters or some trash like that, and you use a Raspberry Pi to create this game that people can play. Anyway, GDScript. That's what I would recommend. It wouldn't necessarily have to be GDScript. There are other lightweight kinds of programming language game engines like SDL or things like that. But if you want the full game engine experience with like the user interface and the, you know, all the kind of editor tools that you would get, something like GDScript is probably your best bet, and I would recommend that for a lightweight kind of solution. All right, I'm just kind of keep on going down the line here, right? If you need some kind of freaking photorealistic simulation or some crazy thing like that, I think this should go without saying. It's not the language that matters. It's the engine that matters. And so in this case, I would recommend something like Blueprint, right? So if you need some photorealistic simulation or some kind of like, or game, right? Then you're going to just be at mercy with whatever the highest end off-the-shelf game engines are using or require. So something like Blueprint, if you want to be able to create this and pass it around easily between team members who don't necessarily know any C++. It's a little bit overkill, especially if your simulation is really not all that, you know, doesn't require all that much heavy lifting. Blueprint really will get you everything that you need. I would recommend Blueprint. That's kind of obvious, right? You know. So anyways, and really, or whatever, Unreal Engine 5. Whatever Unreal Engine 5's secret sauce is going to be. Now, Epic Games acquired ScookemScript's team. Makes you wonder if maybe the Unreal Engine 5 is going to stray away from Blueprint, is going to go back to a, typed or add a typed proprietary language similar to, maybe not like GDScript, but maybe they took a page from the GDScript book and they're going to go with something like that with their Unreal Engine 5 scripting language. Ooh, shoot, I don't know. I haven't been told by Epic, so no NDAs here. I'm probably wrong, but yeah, might as well just throw out a guess while we're at it. This is 2020, folks. All right, what else were we going to talk about? Oh yeah, so if performance, of course, if performance is critical, then you're going to use a native type of language, something like Rust or C, C++, right? So that would be the best programming language, C, C++, if performance is absolutely critical to the application. GDScript, even though it's lightweight, it's kind of slow. I mean, it's not that slow, but it's kind of very slow compared to C++ or Rust, and it has to be. I mean, there's no way it wouldn't be, because it's written essentially on top of a layer which was written in C++, and GDScript it makes all sorts of, there's also, even in C#, right? There's all sorts of generalizations where it's like, I'm going to just declare something. It's like, well, that could be a value, that could be a reference. This period, this dot could be referring to like, a property, could be referring to something else. C, C++, everything is a lot more explicit, and the memory is being managed explicitly. It's going to have higher performance potential. So if you really need to squeeze out the most performance, and you usually don't, then C, C++ is your best programming language. And that's why most of these game engines are written in it, right? Okie dokie, 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 dokie. And then of course, and this almost goes without saying, if you're like developing for proprietary platform, then the proprietary platform. So like if iPhone and performance is critical, because otherwise you could use something like, Unity or Godot or something like that, then you would use the native kind of languages of those platforms, so like Objective-C or maybe freaking Swift or something like that. That's the best game programming language. If it has to be for an iPhone, right? And it has to be, it's mission critical that it's like super, super performant. And usually it's not the case unless you're creating something that's like really kind of pushing the envelope, like some cool augmented reality type of thing, and you're like wanting to write a lot of that, yourself instead of just getting the cool stuff that you would get from Unity. Then okay, Objective-C, Swift, those are your best application. Those are your best programming languages for that. So holy moly, what's the best game programming language? A lot of them are the best game programming language, right? Well, it depends on the application. But what's my favorite game programming language? I don't know. It's like asking me, like, what's your favorite game? Don't ask me that. Well, what's the best game programming language? I feel like GDScript has an incredible amount of potential. Okay, it's kind of slow and it's really freaking buggy with its type GDScript. Hopefully they'll fix all that with 4.0. And when I say slow, I mean there's a lot of currently missed opportunity in terms of using the type GDScript to be able to make use of static typing for performance benefit. Hopefully, again, that will be added with 4.0 of Godot. But GDScript, it's clean, it's what is it called? It's intuitive, and it's very domain specific, specifically game development. But it's specific to Godot, right? So it only works in the context of Godot. Godot's pretty cool, but it only works for Godot. So I think GDScript is definitely one to look out for. But guess what? There could be anything around the corner, right? So for example, Firefox or Epic Games might create some open standard visual scripting or language that like becomes ubiquitous in a bunch of different platforms, so that and that might be kind of like the de facto visual scripting standard that other game engines start to like implement. Probably not, because again, when we're talking about embedded scripting language, it's very specific to that that engine or that context. But who knows? Something else might roll around the corner and become kind of the cool thing. Not sure at this point, but I think if you really, really, really want to, you can make your own game programming language exactly tailored to your needs, and therefore the best game programming language is the one that you make. Highly irresponsible advice. I highly don't recommend it. And I hope you learned a lot this session, and hopefully I'll see you in the next video. And until then, wishing you peace.